Good day, learners. Today we are going to discuss about free fall motion. Let's have a quick summary of what is a free fall motion. Free fall is a motion exhibited by any object under the influence of gravitational force alone. Air resistance is neglected. The first GIF, which is here, shows a ball that is dropped from a specific height. The ball is considered as a free-falling body. On the other GIF, the ball is thrown upward and goes back downward. The ball is still considered as free-falling body in this case. So the condition in which we can say that an object is in free fall are the following. First, the object does not touch anything. And second, it is in a vacuum that we can breathe. So we must neglect the air resistance. Here I have a video clip that shows objects fall towards the earth at the same time, regardless of their mass if air resistance is neglected. So it is against in our uh, conception that heavier object falls faster than the lighter object. So if there's no air resistance, all objects fall towards the earth at the same time. And then on what rate? Okay, this is the acceleration due to gravity on earth. Okay, the value would be 9.81 meter per second squared. But in your book, it says 9.81 or 9.8 meter per second squared. So here we're gonna use 9.81, but in your book it's 9.8. Next would be we will discuss the mathematical concept of free fall. Since the objects that falls toward the earth undergoes the same acceleration, which is 9.81 meter per second squared, so we can use this for kinematic equation because we can use this formula if the acceleration is constant, meaning not changing. And then here, there's the physical quantity, and then the symbols, and then the respective units. So I purposely made this one because it follows what's in your book. So some books, for example, in the other sources, the initial velocity is VI, but in your book, in your physics book, it's VO. In some references, the final velocity is VF, but in your book, it's letter V. And for the acceleration, in your book, it's A, but in other references, it's G. So for uniformity, we will use these symbols. We will follow your book. Understood? Okay. So let's try to analyze this problem and let's see if how can we use those formula. So here's the problem. A ball is dropped from rest at the top of a 73.0 meter tall building. How fast will the velocity be when it hits the ground? Here are the choices. Now, in solving physics problem, you have to create first an illustration in order to have a clearer grasp of what the problem is all about. So here, I'll draw. Here's, let's say for example, a ball, the boy holding a ball. Don't mind my drawing. Oops, oopsie. Okay, he's holding a ball. Okay, a very big ball. And then he drops it. Okay. Okay, he drops it. Okay, going down. okay, in this direction. Okay. Now, for simplification, we will just account the height of the boy uh, into this 73-meter tall building, just for simplification. So, what do we have here? First is, okay, we have the y, the symbol for displacement, okay? That's 73. Oopsie, 73 meter. Okay. Okay. And then, okay, but on what direction? So it starts from top and then it goes down. So it must be negative 73 meter. Okay. What else? So aside from displacement, we also know that the ball initially is at rest. So meaning we have here the initial velocity, okay, would be 0 meter. Why is it man? It's because it's at rest. Okay, here. Next would be the acceleration. And what would be the acceleration? It's 9.81 meter per second squared. Okay. If you use 9.8, it's perfectly okay. So, and in what direction? It always goes downward, so it's negative. So to summarize, we have this. So we have the given. We change the color. Okay, maybe this. Okay, the displacement. And then we have the initial velocity. And then the acceleration. Please do not forget the direction. You might be asking again, oh, sir, why is it negative? It's negative because it goes downward. Okay, next would be what's being asked. In our term, so may gipangita. So here, the velocity, specifically the final velocity, because here is the main question: how fast will the velocity be when it hits the ground? So perfectly, it is saying that we are asking for the final velocity. Next would be the formula, and here's the trickiest part. Okay, so among these four, okay, formula that, oops, that I gave you, what formula are we going to use? Okay, so how to use this table here? So first, you have to find where is the ask. Okay, okay, here, and then check if in the given formula is there final velocity. So let's check. Yeah, I'll give this numbers for easier reference. Okay, here. So for 1, do we have final velocity? Yes. Okay, we have this. Okay. For 2, do we have final velocity? Yes, we have this. For 3, yes. And for 4, do we have final velocity? The one being asked, none. So we would immediately eliminate formula number 4. Next would be go to the given. For the given, we have the y. We have the value for the y. So we have, or the displacement. Do we have y here? No, we don't have. How about for formula number 2? Yes, we have. For formula number 3, yes, we have. Next would be this one, the initial velocity. Do we have initial velocity for the remaining formulas? Yes, here. How about here? Yes. How about for acceleration? Do we have acceleration for number 2? No, I don't believe we don't have. So we would eliminate. And this formula number 3 would be the formula that we're going to use in order to solve this problem. So I hope this one is clear. So what's the big lesson here? In solving physics problem, you must know how to get the given. This is very important, okay? And then what's being asked. Because once you know already all the given and then and also what's being asked, okay? It would be easy for you to get the formula. Okay. So here we have this, okay? And then plug in all the numbers. We have for initial velocity, we have it here. And then for y, we have it here. And for a, we have it here. Okay. So I have here a calculator. So I'm gonna give this one to you. So how to plug it in? Let me uh, do this in my own calculator. 2 times negative 9.81 times negative 73. Okay, you don't need to put a point zero. It won't matter. Okay, we have this number, but remember, there's still squared here. Okay, so you square the answer and then to get this one. Okay, so here, okay, and then there's still squared here, so to get rid of it, you square both sides just like that, and then you get this number. But the question is, sir, why is it negative? Okay, why is it negative? First, okay, once the number is being uh, square root, okay, the answer that you can provide is either positive or negative. Okay, so you have now the two options, whether you're going to use the positive or the negative. But remember, in our illustration, let's go back to this slide, okay, the ball is going downward. And we all know in our Cartesian plane, okay, this is the x-axis and this is the y-axis. X here is positive, here is negative, this one is positive in the y-axis, and this one going down is negative. So it is a negative. So here, okay, why is it negative? Because the ball is going downward. So, so you can write your answer like this, or you put the negative sign out and then change it into word down. So I hope this one is clear. So you have now your answer.